Hello! Welcome to today's lesson on Hooke's law and the limit of proportionality. We will begin today's lesson by exploring how Hooke's law describes the behaviour of elastic materials, like springs, when stretched or compressed. Next, we'll learn the mathematical representation of Hooke's law, F equals KE. We will then discuss what happens when the force exceeds the limit of proportionality, leading the material to behave non-elastically and potentially undergo permanent deformation. Finally, we'll work through some problems together to consolidate our knowledge. So far, you have learned the distinction between elastic and inelastic deformations. Elastic deformation is reversible, where an object returns to its original shape after the force is removed, while inelastic deformation is permanent. Building on the knowledge of elastic and inelastic deformations, today we will advance our understanding by exploring how Hooke's law governs the behaviour of materials within the elastic range and what happens when this limit is exceeded. Let's get started. Hooke's law is a fundamental principle that describes the behaviour of elastic materials like springs when stretched or compressed. It is named after the 17th century British scientist Robert Hooke. This law states that the extension or compression of an elastic object, such as a spring, is directly proportional to the force applied to it, provided the limit of proportionality is not exceeded. To understand this intuitively, think about pulling a spring. If you pull it slightly, it stretches a little. If you pull it more, it stretches more. The same principle applies when you push or compress the spring. The more you push, the more it compresses. This is because the spring resists the applied force and tries to return to its original shape. Hooke's law gives a mathematical description of what we're seeing here. Let's turn to it in more detail now. The mathematical representation of Hooke's law is force F equals spring constant K times extension or compression E. F is the force applied to the spring. It is measured in newtons, N. K is spring constant, a measure of the stiffness of the spring. It is measured in newtons per meter. The higher the value of K, the stiffer the spring. E is the extension or compression of the spring from its original length, measured in meters, EM. For example, if a spring has a spring constant K of 50 newtons per meter, and we apply a force, F, of 10 N, we can calculate the extension, E, as E equals F over K. So E equals 10 newtons over 50 newtons per meter equals 0.2 meters. This means the spring would stretch by 0.2 meters when a force of 10 newtons is applied. While Hooke's law holds true for many materials within a certain range of applied force, every material has a limit. This is known as the limit of proportionality. Beyond this point, the material no longer behaves elastically, and instead, it may undergo plastic deformation. Elastic deformation is when the material returns to its original shape after the force is removed. Plastic or inelastic deformation is when the material is permanently altered and does not return to its original shape. Think of pulling a spring so hard that it becomes permanently stretched. Up to a certain force, the spring will return to its original shape, but beyond the limit of proportionality, the spring will not return to its original shape and will be permanently deformed. Let's apply what we've learned to a few specific physics problems to consolidate our understanding of Hooke's law. Problem 1. Calculating force for a simple extension. A spring with an initial length of 0.5 meters is stretched to 0.6 meters. The spring constant is given as 30 newtons per meter. Let's find the force involved in this distortion. Start by identifying the given values. The initial length is 0.5 meters, the final length is 0.6 meters, and the spring constant, K, is 30 newtons per meter. Next, calculate the extension. This is the final length minus the initial length. A equals 0.6 meters minus 0.5 meters, which equals 0. 1 meters. Now apply Hooke's law. Force F equals sign, spring constant, K times extension. This is 30 newtons per meter times 0.1 meters, which gives us 3 newtons. Therefore, the force applied to the spring is 3 newtons. Problem 2, working with smaller numbers. A spring with an initial length of 0.3 meters is extended to 0.32 meters. The force of the distortion applies to the spring is 0.5 newtons. Let's try and find the spring constant. First, identify the given values. The initial length is 0.3 meters, the extended length is 0.32 meters, and the spring constant, K, equals 0.5 newtons. Next, calculate the extension. This is the extended length minus the initial length. So 0.32 meters minus 0.3 meters, which gives 0.02 meters. Now apply Hooke's law. Force F equals spring constant, K times extension. 0.5 equals K times 0.02 m. K equals 0.5 over 0.2. Therefore, the string has a spring constant of 25 newtons per meter. By working through these examples, we see how Hooke's law can be used to relate the force applied to a spring with its extension or compression, emphasizing the practical applications of this fundamental principle in physics. In today's lesson, we delved into Hooke's law and the concept of the limit of proportionality. We started by understanding Hooke's law, which describes the direct proportionality between the force applied to an elastic object like a spring and its extension or compression, as long as the limit of proportionality is not exceeded. We learned the formula F equals sine KE, where F is the force, K is the spring constant, and E is the extension or compression. We then explored what happens when the force exceeds the limit of proportionality, leading to non-elastic behaviour and potential permanent deformation. By understanding these principles, we can better appreciate the behaviour of materials under different forces and apply this knowledge in practical scenarios. Watch the rest of the GCSE physics course at Sophos Education.